Calculating the pH using a limiting reagent problem is a really common calculation in the WACE. You can expect at least one of them. So we need to be able to practice how we do them. So let's get started. So I'm reading my problem. I've got 50 ml of 0.02 molar sodium hydroxide. So underline my key point here. And I've got 50 ml of 0.02 molar sulfuric. Immediately I should have some alarm bells going off. Ding, 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 ding. It is a limiting reagent question because I can find two sets of information. Now this is a stoichiometry. For every stoichiometry we have to have an equation. So that's what I'm going to do. I'm going to write my equation. My equation is a neutralization. Hydrogen ions plus hydroxide ions gives water. So let's get started. For any stoichiometry, I have to find a mole. So that's what I'm going to do now. I'm going to find the number of moles of sodium hydroxide, which is equal to CV. So the concentration is 0.02 times 0.05 for the volume, which is 0.001 moles. Now the number of moles of hydroxides will be the same because each mole of sodium hydroxide dissociates to release one hydroxide ion. Now let's do the number of moles of sulfuric acid. So the number of moles of sulfuric is equal to CV, which is equal to the concentration, which is 0.02, times the volume, 0.05, which is 0.001 moles. Now our equation is not using sulfuric, it's using hydrogen ions. So we're going to have to find the number of moles of hydrogen ions. Now what you will note with sulfuric is that it's diprotic. So this means that when it's put with a strong base, it will release twice as many hydrogen ions. So we're going to go, the number of moles of hydrogen is 2 times the number of moles of sulfuric, which is 0.002 moles. So we've already established that it is a limiting reagent question. Now we have to work out what is the limiting reagent. And that's actually really straightforward because it's in a 1-to-1 ratio. Now if I look at this, I've got 0.001 moles of hydroxide ions and I've got 0.002 moles of hydrogen ions. So this is telling me that my limiting reagent, the one that's going to be used up first, has to be the hydroxide ions. Now I'm going to have to find the number of moles of hydrogen ions that are used. So we're going to go 1 mole of hydrogen ions reacts with 1 mole of hydroxide ions. So X moles of hydrogen ions are going to react with 0.001 moles of hydroxides. Once again, it's pretty easy because it's a 1-to-1 ratio. So the number of moles of hydrogen ions that were used will equal 0.001 moles. Now, even though it was really straightforward, I still make that statement. We want our marker to be our friend, so we want everything to be clearly set out so the marker can instantly follow what you are doing. So, we found the number of moles of hydrogen ions used. Our next task is to find the number of moles of hydrogen ions left over, which are the excess ones. So that is equal to the number of moles of hydrogens from the start minus the number of moles of hydrogen ions used. So using this, number of moles of start were 0.002 minus 0.001. So we've got 0.001 moles in excess. Now a pH is the power of hydrogen ion concentration. At the moment we've got the moles, so we're going to have to find the concentration of these hydrogen ions. In order to do that, we need the moles and we need a volume. So the volume will equal the total from both solutions, 50 ml add 50 ml, which equals 100 ml, which in turn is 0.1 of a litre. So our concentration of hydrogen ions is equal to number of moles divided by volume, which equals 0.001 divided by 0.1. So this will equal 0.01 molar. Now the last thing is we have to find the pH. So a pH equals negative log of the hydrogen ion concentration, which equals negative log of 0.01, which equals 2. Now if I look at my initial information, this one has 3 significant figures, this has 2 significant figures, this has 3 significant figures, and this has 2 significant figures. So my final answer needs to be given to 2 significant figures. So 2.0.